All right, so yesterday we talked about the distance formula, kind of. We didn't give like I don't think I gave the official formula, but I'm going to now. All right, I'm not going to review that. You can always go back on the YouTube and look at what we did yesterday. But let's do this. I should have had this ready, but that's okay. Let me copy that. Let's put that here. And, oops, come on. There we go. Stretch this out a little bit. All right. What do we call this whole thing right here?
Cartesian plane.
It's a Cartesian plane. That's right. Okay, we'd never called it a grid yesterday. Okay, we called it a Cartesian plane. There's another name that a lot of teachers use, and we can use it as well. We call it a coordinate plane, or sometimes I think they say rectangular plane. They might. I don't know. But coordinate plane or Cartesian plane are the most famous ways we say this.
Grid's the wrong term. That's what I was taught like all throughout.
I've never really heard a math teacher say grid. I mean, technically it is a grid, but we don't really refer, when we have an X and Y axis like this. Okay, I'm in the middle of teaching, guys. Thank you. Sam, let's face the front. So, answer your question. Math teachers normally call it the Cartesian plane or coordinate plane. All right, like I said, technically, yeah, it is a grid, but we don't really refer to it as that. All right, we talked about X, Y axis. I'm not going to go through that. I will go through this part right here. Remember, we just picked two random points, and we actually found out what the points were. What if I didn't know what those points were? In fact, let's do this. Let's not use this Cartesian plane. Let's do this. All right, and this. All right, so what if we had this, and we had a point? Let's do this in a different color. What if we had some random point? I'll tell you what, we went kind of this way. Let's go the other way today just to be different. All right, so let's say we had 2 points here, and we want to find the distance between these 2 points. Now, yesterday we had the, now Ben, you got me saying grid, almost said grid. Now we had those coordinates yesterday. We could count over, right, exactly where it was. But right here, can you count over? Do you know exactly where that point is right there? No, because I haven't marked it off or anything like that. So you don't know exactly where that point or where that point is. We'll call this point 1, all right? We'll call this point 1, and we'll call this point 2. Well, a point has an ordered pair associated with it, correct? All right, so what are the letters that we use for ordered pairs? X and Y, all right? So if this is, now watch carefully. If this is point 1, we're not just going to call this X and Y. We're going to call this, what do you think? How about X1 and what? Y1. It's point 1, all right? So point 1 has an X and a Y to point 1. So we'll call it X1, Y1. Make sense? Now, that should make more sense down here now. So what do you think we're going to give the coordinates to this point? This is point 2. Very good. X2, Y2. Make sense? All right. So this is X1, Y1. This is X2, Y2. It just represents any points on this Cartesian plane, right? I just don't know what they are. So I'm just going to be real general about it and call it X and Y, and this is X and Y. If I call this point 1, call this point 2, this is X1, Y1, X2, Y2. We good with that? All right, let's do something else. Change colors here. What if I go from here straight down? I'm trying to go even with that point. Does that look about right? It's close enough. And that right there. I was almost there, wasn't I? Let's see if I can. There we go. Close enough. I thought I changed the color of those, but I didn't. There we go. Let's even change that one. Didn't we use green yesterday? So we'll stay the same color. All right? Everybody good with that? So we did this yesterday, but we actually knew what the points were, so we could count over and count down and that kind of thing. But what about, keep this in red. What about this point right here? What do you think I'm going to call that point? This one right here that I just drew. So if you start here, so how far over to the left did we go? Look at these points, x1, y1, x2, y2. We started here. How far over did we go to get, to get over top of this? Yeah, you do. Yeah, you do, because you know how far you went over to get to this. How far over did you get to this point, to the left? How far to the left did you go? We don't know the actual number. Say it, Jack. We went over x1, didn't we? To get to this point right here, what did we do? We went to the left. How far? x1. So if we're right over top of this point, how far over did we go to get to? We went over x1. So what's the first part of this point right here? It's x1. Okay? Everybody see that? Now, to get to this point 1, we had to go up y1. But we're not going up. We're going down here, aren't we? So how far down did we go from here to here? We went y2 because that's the same distance from here to here, isn't it? All right. So what's this going to be? This is going to be x1 what? y2. You with me on that? All right. So we went to the left. How far did we go to the left? x1, because that's how far we went to the left to get to that. And then we went down. How far down did we go? Well, we went down y2 to get to here. So we also went down y2 to get to here. I think that finding that point is pretty important because of what we're going to do right now. Remember, I don't know, a couple, 3 weeks ago, we talked about the distance between 2 points. We mentioned this yesterday. Yes? Okay, so if I said this was 5 and this was 1, what is the distance from here to here? It's 4, isn't it? All right, so, right, if you start at 1 and you go to 5, it's not 5 over. I heard somebody whisper 5. But it's 4 over. How did we do that? What math did we do? Right, we went 1 minus 5, or you could go what? 5 minus 1. It doesn't matter what order you subtract them because the distance is always what? Oops, why did I put 4? I was getting ahead of myself. 1 minus 5. Because this is negative 4, but we always take the absolute value, right? We always get a positive version of it. And you're going to see that these are always going to come out positive as well. Not necessarily because of the absolute value, but because of something else. We'll talk about that in a second. All right. Everybody with me on that? That's how we find the distance between 2 points. We just subtract 2 distances, okay? So now, watch this. What I want to do is I want to find the distance of that yellow line right there, okay? It's up and down, isn't it? Okay, it's up and down. So how do I find the distance between, let's just draw it. How do I find that distance right there? We can't count. We don't have any things. Very good. Okay, you could go y1 minus y2 because this is the y point right here because we're going up and down. I'm not going to do the x's because the x's are exactly the same, aren't they? All right, so I'm going to do the y's. I could go y1 minus y2. Now, a lot of math books do this. It really doesn't matter. Remember we said the order that you subtract them doesn't matter? All right, so I could call it y1 minus y2, or I could call it what? y2 minus y1. It doesn't matter. But I'm going to do it this way because most math books will do it this way. They usually go y2 minus y1. That's the distance of the yellow.
That's what it showed on the book and everything I looked up.
Yep, everywhere it does. But again, just so you understand, does it really matter what order you subtract them in? Doesn't matter, okay? And you're going to see in a second why. All right, let's do the green one. So what do you think the distance of that green line is? Right, that's right. You just subtract the x's, okay? Everybody with me on that? All right, so again, the book usually says x what? 2 minus x1. And again, it doesn't matter what you do here. What are we trying to find, though? What's the whole idea behind this? The whole idea is to find what? The distance of the, which one? The red one, okay? No, we haven't mentioned the word slope yet, okay? And we won't on the distance, okay? We will a little bit later on. Maybe today if we, right. So we're trying to find the distance. We're trying to find how long is that red line right there, okay? That's what we're trying to find. You can't just count, boom, boom. Remember we did that yesterday? You can't just count on those little grids, all right, that are on there, on the Cartesian plane, all right? But there's a way to do that. What kind of a triangle? We've made a triangle here. What kind of a triangle have we made? We made a right triangle, all right? And in Algebra 1, you learned a thing, and we learned it yesterday. Let's go back to white. We learned it yesterday, and it's called the what? Do you remember? Right, Pythagorean theorem. Why such a weird word, Pythagorean? That's right. There was a guy named Pythagoras. He didn't really come up with this theorem. I don't know if you mentioned this, if you remember this from yesterday. I mentioned it, right. Yeah, I only mentioned it once, but he's the one that proved this theorem, okay? Don't worry about that. There is a way that we can show how to prove it. We're not going to do that in here, okay? Maybe some other time, but not today. So, well, we just have to know what the Pythagorean theorem is. In general, what is the Pythagorean theorem? It's what? A squared plus b squared equals c squared.
And then what would you divide it by? I know you divided it.
Well, I'll show you. It's not a division. It's not division. But we'll get to it in a second. I'm going real basic right here. It's a squared plus b squared equals, it's easy as ABC. That's what I tell kids all the time. Pythagorean theorem is as easy as what? ABC, because a squared plus b squared equals c squared, okay? As far as the color of the lines right here, which one is the A?
Yellow.
It could be the yellow or it could be the green one. Doesn't make any difference, okay? What about the B?
Wait, my fault.
So if I said A was the yellow one, then B would be the what? The green one. The green one. The green one. The A and the B are the two sides, listen, or we call it the legs of the right triangle. So the A and the B, it doesn't matter which one. This could be the yellow one, this could be the green one, or vice versa. Everybody with me? But what always has to be true, is the C always has to be what? Well, yep, in this case, it is the red one, because I did tell you to tell me by the colors. What kind of fancy math word do we use, though, for the red one on a right triangle? Well, we are going to find the distance, but as far as just the triangle itself, it's a fancy math word. What do we call it? I think you might have written it down yesterday. Yeah, it's the hypotenuse. It's the hypotenuse. C is always, whoops, that's a weird Y, but anyway, you get it. It's hypotenuse. If I write too small, it looks weird. All right, there we go. Yes, sir. Well, we're going to do that in a second. Oh, yeah, right there, you mean? Yeah. But we knew this was vertical. We knew this was horizontal. So that's definitely a right angle. All right, we good with this so far? Now, let's forget A, B, and C, but let's look at the distance. What is the length of A? We'll call the yellow one A, and we'll call the green one B. All right? What is the length of A? Look, it's written down. It's right in front of you. That's right. It's y2 minus y1. So that is the length of A. Now, we could also write it like this. Would you agree that I could have also written it like this?
Yeah.
Doesn't make any difference, does it? I'm going to write it like this, okay, with the C out in front, right? It doesn't matter, right? 3 plus 4 is 7, right? 7 equals 3 plus 4. Is there any difference? No. All right, so it's the same thing here. So let's scooch this up just a little bit. All right, so what I want to do this. Let's go back to this, and I'm going to throw another letter in here, but I'm going to show you why. I'm going to call that red one, I'm going to call it D. Now, look, there's no D on here. Why in the world would I call that D? It's the distance, exactly right, because I'm trying to find the distance from this point to this point. That's why I call it D. You with me on that? It has nothing to do with A, B, and C, but so D on this picture is really what in my theorem? It's really the C. It's really the hypotenuse, okay? So that's why I'm doing that. So with that said, if I confused you yet? So here's what we have. Let's keep this in white. So instead of C squared, what are we going to write? What did we say the C was? Right, we're going to write D squared. Now, watch very carefully. This is where we get into it, okay? We're going to actually write down what the distance formula is. That's what we're doing, and I'll write that down in a minute. But what is the distance formula? Well, the distance formula is the hypotenuse squared equal to the A squared plus the B squared. So what is the A in this picture right here? It's y2 minus y1, but what do we have to do to it in the Pythagorean theorem? We have to square it. Everybody see that? Okay. So write out the rest of the Pythagorean theorem. Plus what? That's right. Now it's the B. If we consider the green one to be the B, yeah, I don't know why I did the y's first. It doesn't make any difference. But x2 minus x1. Usually I would put the x's first. And then what do we do with that? We square it. Why do we square these things? Because it's a right triangle and we're applying the Pythagorean theorem. Does that make sense? That's why we're squaring that. Why did I write y2 minus y1? Because that's the distance of one of the sides of my right triangle. Why did I put x2 minus x1? Because that's the distance of the other side of the right triangle. You with me? Okay. And the d, why did I call it d? Because it's the distance is what we're trying to find. Now, this is how you're going to see it in the book. I think they put the x first. Anybody got your book open? Did they put the y first?
Yeah.
Okay. Okay, that's fine then. But again, it doesn't matter. Notice, does it matter if I go y2 minus y1 or y1 minus y2? No, because we're doing what to it? We're squaring it. So if I square a positive number, I'm always going to get a positive number. If I square a negative number, I'm always going to get a positive number, okay? So by squaring, right, because negative times negative is positive. So if I'm squaring this, it doesn't matter what order I subtract these in. Now, Ben mentioned slope. We're going to do slope here in a minute. It absolutely does matter, okay? Same with midpoint. It matters what order you subtract them in, okay? On the distance, it doesn't because we're squaring it. And it's going to it's going to force it to be positive. You got it? So let's do this. Let's get d by itself. Do you remember doing this when you did, like if I said x squared is equal to, I don't know, 16. You remember this? Okay, and I wanted to get rid of the squared. We always do the opposite, don't we? What do you think the opposite of squaring something is? It's not dividing. Square root. That's right. Square root is the opposite of squaring. Okay, so if I do it to one side, I do it to the other side. What happens to that square root and that squared? They cancel each other out because they're opposites of each other. Okay, so really that square root and that square, and now what do we get? We get x by itself. You with me on that? Let's go to this one then. So that wasn't too hard to understand. Right, x is 4. Okay, what about this one right here? How do I get d by itself? And what is it? I just did it right here. How do you get rid of a square? I know, but how do you cancel it out? We don't just say we cancel it out. We got to take the square root. That's right. Okay, we got to take the square root. That gets rid of a squared. Does that make sense? If something's being multiplied by x, you divide it, right, to get rid of it. If something's being added to it, what do? You subtract it. If something's being squared, how do you get rid of the squared? You take the square root. Okay, that's the opposite. We good with that? All right, so even if you didn't learn that in Algebra 1, now you're learning it. Okay, you got it. So what do I have to do to the other side? Okay, taking the square root of this cancels them out, right? So I'm just left with d. So now, here it is. This is the way you're going to see the distance formula in most math books. It's going to look like this. y2 minus y1 squared. It looks crazy. If all I did was start today's class and said, okay, here's the distance formula. Memorize it. This is what the x1 is. This is what the y1 is, and all that kind of stuff. I mean, you could probably do the problems, but you'd probably have no idea where this crazy thing came from. But now, hopefully, you understand exactly where we got all this stuff, right? This is right here. That's the length of one of the sides of my right triangle. This x2 minus x1 is another length of the side. Okay, the d is the distance. Okay, why did I square them? Because I did a Pythagorean theorem. Why did I take the square root? Because I had to get rid of the squared over here with the d. Make sense? That's how we got this. So this right here is called the distance formula. So let's write that down. It's going to be used quite a bit. It's a very important formula. This is not just something that is not very important. Okay, we call this the distance formula. There it is. And you're going to need to know it, whether you memorize it or not. Or you could maybe look at it and kind of figure out, why did we get that distance formula? Oh, it's a right triangle. Oh, the length of that side is y2 minus y1. The length of the other side is x2 minus x1. And then what do we do with those? Why do we square them? Because it's Pythagorean theorem. Why do we take the square root? Because you got to get the squared on that d by itself, or you got to get rid of that squared on that d, so we take the square root on both sides. Okay, that's how we get the distance formula. Make sense? Yeah, that's not so bad, I think. My guess is nobody showed you how you got that formula. Have you used that formula at all? Did you use it in Algebra 1? Sometimes they teach in Algebra 1. It's probably maybe later on in Algebra 1. Sometimes you learn it, sometimes you don't.
We did distance, but like not
Not with math? All right. Let's do an example. Oh, you did in science class? Okay, yeah. So this stuff, I mean, this occurs a lot. This is a pretty important thing. So let's do an example. All right. This is example 1 in the book. If you look in the book, it says find the distance. I'm just going to write find the distance between. That's how I write between B, W. All right. Just shorthand it a little bit. So it's negative 2, 5. So they give you 2 points. And 4, 1. So they give you 2 points, and they're asking you to find the distance between those 2 points. All right, I'll tell you what, let's drop that right there so we can see our distance formula. Okay? It doesn't matter which one you call x1, y1, or x2, y2. This could be the first point, this could be the second one, or you could call this the second one, this the first one. But let's just do it first and second. So this would be considered my x1. The 5 would be considered my what? y1. This 4 would be the x2, and the 1 would be the y2. You with me on that? All right, so watch what we do. We want to find the distance, so we write distance equals big old square root. Okay? Now watch what I do. I'm not going to write all this out. All I'm going to do is put a parentheses and a squared plus another parentheses and a squared. This is how I set it up. I call this the shell of the formula, right? I haven't really put any numbers in here except for the squared stuff. But this is what I'm plugging everything into. If you can memorize this part right here, it shouldn't be too bad. Now, what do we do? And again, it doesn't matter if you do the x's first or the y's first. They put the y's first here, but it doesn't make any difference. Let's just stick with what they do so you don't get confused later on, okay? So what do? We just subtract the y's. Now, again, doesn't matter what order we subtract them. It doesn't matter. I could go what? 5 minus 1, or I could go 1 minus 5. It doesn't make any difference. What do you want to do? You want to go 1 minus 5? All right. It gives you a negative. Really isn't that big of a deal. But if I was to do it, I'd probably go 5 minus 1. But if you want to go 1 minus 5, that's fine. Okay? Absolutely. All right. Again, it doesn't make any difference. But you do have to subtract the y's from each other. I cannot do this. Now watch very carefully. I cannot subtract a y from an x. You got it? You can only subtract the x's together, and you can only subtract the y's together. All right? Don't mix them up. You with me on that? Yeah. All right. So I did the y's. Now I do the x's.
4 minus 2.
Okay. Well, it's not 4 minus 2. That's right, because that's a negative 2. Remember, it's 4 minus what? Negative 2. It's not 4 minus 2. It's a common mistake. Okay? He's not the only one. Every year, people do that. Okay? They'll look at it and say 4 minus 2, but it's not. It's 4 minus negative 2. Everybody got it? Okay. So now the rest is piece of cake. The rest is super easy. I promise you, I'm not just saying that. What's 1 minus 4? Or I gave it away. What's 1 minus 5? Well, it's negative 4. But, again, did it matter that it was negative? No, because what are we going to do to it? We're going to square it, right? So it doesn't make any difference. What's 4 minus negative 2? Add a line, change sign, right? It's not 2. It's minus a negative, which is plus. 4 plus 2 is 6. Then what do we do with that 6? We square it. All right, the math really isn't that hard. You don't need a calculator for it. Okay, you just do this in your head. There might be some problems later on where they give you bigger numbers or something like that. You might want a calculator. But so far, have we needed a calculator? No, not at all. All right, let's do this. This is 16, and this is 36. Okay, and that is what? 52? And it's still under a square root, isn't it? There might be a time later where we're going to talk about square roots and how to simplify square roots. For right now, I'm not going to worry about that. We could just put this in a calculator, and I think that's what they want. All right, so I just happen to have a calculator right here, and
I don't. What is square root exact? Is there an exact number square root equal, or is it?
Well, some like the square root of 16 comes out exactly to be 4. Okay, but the square root of 8, doesn't come out even. It comes out to a decimal. And the decimal, you know how pi is? Listen. You know how pi is 3.14159? It keeps on going, and never stops. Okay? It doesn't repeat, but it just never stops. We call that an irrational number. An irrational. because the normal numbers that we deal with are called rational numbers, okay? So 3 is a rational number. Any number that you can make as a fraction is a rational number because the word ratio is in the word rational, okay? And a ratio is a fraction, okay? So 0.5 is rational because it's a half, all right? If it stops, okay, even if it repeats the same thing over and over again, like 1/3 is 0.33333, right? That's still considered a rational number because it repeats something. But pi is 3.14159, blah, 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 forever and ever, and the numbers keep changing. That's irrational. So the square root of 52 doesn't come out even, right? Like in our head, if we wanted to figure out approximately what it is, what's the closest number just below 52 that you can take the square root of and it comes out even? 49, right? Would you agree? Square root of 49 is 7. So 52 should be what? 7 point something, okay? You with me on that? Okay, so it should be 7 point something. So what do? On this one, on this particular calculator, if you have one like this, I hit the second function and I hit that right there. Do you see the little square root? Okay, so it even shows you a little square root symbol. Put 52. For some reason, when I click with my pen, it doesn't click on this calculator. You don't really have to close the parentheses, but I don't know. I'm kind of OCD and I kind of like to make it look real nice, but it doesn't make any difference. I hit enter and there it is, 7 point something, okay? Let's just round it to the first decimal place. So what does that round to? Just 7.2 because the 1 does not round it up. When would it go to 7.3 if what? If this was a 5 or higher, okay? Now look at the decimal. It looks like the decimal repeats, doesn't it? You got a 1, a 1, and a 1, but then it starts going crazy, right? 0, 2, 5, 5, 1. And if I had a computer and I put it in and it went out unlimited decimal places, it would just be, to us, it would just be some random numbers, okay? That means it's what kind of a number? An irrational number. It's IRR, okay? Irrational number, okay? So we're just going to take it to one decimal place. Whoops. Let's try this again. 7.2. Technically, I shouldn't put an equal sign here. I'm being really picky because it's not exactly 7.2. It's a what? It's approximately. Remember the little squiggle equal sign? Okay, it's approximately 7.2. Would I mark it wrong if you put an equals there? You'd probably think I would, wouldn't you? Because I take points off for everything. But I would not. Okay, I would not. If you put equals, if you just put 7.2 and circled it, I'd be fine with that. Okay. Now, if I specifically say to round it to one decimal place, then I want exactly 7.2 here. All right. If you put 7.21 and I ask you to round it to one decimal place, is that rounded to one decimal place? No. So what am I going to do? I'm going to mark it wrong. All right. I'm sorry. You did all the work. You got it basically right. But if you don't follow all the instructions, you're not going to get the credit for it. Okay. Just got to get used to that. So that's not too bad, is it? What do you think? What?
I thought it was pretty good.
Yeah, I don't think that's so bad. All right, let's talk about something else real quick. Let's get that let's see. Yeah, let's get that grid. I still got it here. Yeah, go ahead.
During the test, we just plug in the calculator by line and just write what it says.
Plug what into your calculator? I mean, you're going to have to do all the work.
Yeah, they just
I mean, you can't just plug these into a calculator.
no.
All right, you got to put it into there. The square root stuff.
Yeah, like the biggest.
Yeah, it's up to you. If you want to do that, that's fine. Okay. If you get to this point right here and you just want to chuck all this into a calculator, I'm okay with that. Okay. But here's the deal, though. I don't want to see this. Watch. Here's the question. I don't want to just see this. You with me on that? Okay. I want to see what you're putting into the calculator. All right. You got it? So this would be, well, I don't know if I give it to you. It just depends how I feel. Okay. I would probably, if it's a homework, watch, if it's a homework and you've got 1, 2, 3, 4, and here's your answers. 5.1, 7.2, 8.3, 1.9. If you have this, I'm going to probably put a slash through it, and I'm going to say, show your work. Okay? And I might, If I'm really feeling kind of salty, I might put an exclamation point there. Okay, that'll show you. All right. So, if I'm really feeling it, I might do that. Okay. But the problem is, if you have 20 problems to do, and this is all you have, I'm going to give you a big old fat 0 for it. You got it? All right. Because I don't know what you did. I don't know how you got those. The whole idea of doing your homework is showing me that you know kind of what you're doing. Okay, I'm not looking at, you could get every single one wrong, but if you showed all your work, okay, let's get rid of all of this. Where was I? There we go. Okay, if you showed all this and you put the wrong numbers in here, you didn't do your subtraction right, this is still okay for a homework, right? I wish you'd get it right. What you should do is do the homework, look in the back, see what the answer is. If you didn't get it right, go back and try it again so you get it right, okay? I wouldn't try it 5, 6, 7 times because then you'd never get your homework done, all right? Try to find your mistake quickly, make the correction, go on to the next problem, all right? If you still have a question on it, you don't know how to do it, ask it in class and we'll go over it in class. All right, we got to talk midpoint right here. I don't know if we'll get to slope today, but at least we'll get to midpoint. All right, so midpoint. We actually had a quiz question with midpoint on it, didn't we?
Yeah, line.
Yeah, put a line segment, then you put a dot right here. Okay, if I said, listen to me now, if I said this whole distance right here was 10, okay, right? Well, I shouldn't say that. Let's not do that. What if I said that this was 2 and this was 12, okay? And I asked you to find m. Okay, you've done this before, all right? So do you remember what we did? You could do this. You could subtract them. The whole thing is 10, and then so half of 10 is what? 5, and then add it to the 2. So this would be what? But there's a better way to do it than that, okay? And I think I've shown you this before, but watch what we could do. How can I get this to be a 7 with these two numbers? What's the easiest way I could take those two numbers and get a 7 out of it? Come on, I'm not done. That's a 2 and a 12. All right, I said it when I wrote them down. This is 2, this is 12. Okay, this is the midpoint. What's an easy way I can take 2 and 12 and get a 7 out of it? Go ahead, Alex. Exactly right. Okay. See, look, I can add them up and divide by 2. You with me on that? So what is that? That's 14 divided by 2, which is 7. That's how you find the midpoint. Listen to me. You add them up and you divide by 2. Okay? So now, let's do this. I'm going to actually put some points on the line so we can count. Okay? So let's put one right there, and let's put one right there. And let's connect them. Now, this question is different. It looks the same, okay, because I'm going to give you 2 ordered pairs, but it is different because we're finding midpoint. We're not finding how long that line is now. That was the other question. This time, I'm trying to find out where in the middle is this thing. It's probably in here somewhere, isn't it? Okay, but it's not just like a 7. It's an ordered pair, isn't it? I got to start here. I got to go over, then I got to go up. Okay, and I got to find out where that is. I can't just guess. All right, I might get lucky and guess, but I can't do that. What do you think? Exactly right. You've got it. Okay, so if I call this x1, y1, and I call this x2, y2, do you see why I did that earlier? Because we're going to do it here as well. We're going to do it with the slope as well. All right, so what you could do is this. Now watch. Let's go with the same color scheme as we did before. So the one that goes across is green. So what I could do is that. Can you see that green? Yeah, you can see it pretty good. All right, and let's go to yellow. And let's go from here to here. Okay. You with me on that? So watch how I can find the midpoint of the red one. If I found the midpoint of the green one, right? So 1, 2, 3, 4, 5, 6, 7, 8. Oh, did I count right? I missed. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So what's half of 9? It's 4.5. So it's somewhere in here, right? Right in there probably. I don't know. All right. And then I'd find half of this. So if I go halfway over here and then halfway up the yellow, guess where I'm going to be on the red? I'm going to be half. I'm going to be the midpoint of the red one. Does that make sense? All right. Let's put the actual numbers in here, okay? Let's put the actual numbers in here. So what is this one right here? This is 1, 2, 3, 4, 5, 6, -6, -1, -6, -1. Agreed? What's this point up here? It's 1, 2, 3, 1, 2, so it's 3, 2. All right? So if I find, what's this point right here, though? That's an important point. It's what? 3, -1. Okay? So watch what I'm going to do. I'm going to find the midpoint of the green one. So I've got these 2 points right here. How do I find the midpoint of the green one right here? Well, I find the midpoint of the x's, right? So where am I? I'm at -6 here, and I'm at 3 here on the x-axis. So how do I find midpoint? I add them up, divide by 2. So what are the 2 points? -6 plus, this time, what? 3. And then I divide by 2. That's -3 divided by 2, which is negative what? Yeah, 1.5 or -1.5, right? So on the x-axis, where do I go? I go -1.5. That's the midpoint right there. You with me there? We're almost done. Okay? Let's just finish this up because the bell's going to ring in a couple minutes, okay? What about right here? Don't pack up. I didn't say pack up. I said we're just finishing teaching, okay? Don't pack up. What about the midpoint up and down right here? Okay, so what do we do, though? We take the y's, we add them up, 2 and what? -1, and then we divide it by 2. So 2 plus -1 is 1/2, all right? So that means, what do? I go over on the x, -1.5, and I go up on the y, 1/2. And that would be right there. It's pretty much where I guessed, all right? But that's your midpoint right there, okay? Let me write the formula out with the x's and the y's, okay? So here's the midpoint formula. I'll just shorten it, midpoint formula. Now, there's no square roots or anything, all right? It's just a point. It's not a distance. It's not just a number. It's a point. So the point is x1 plus x2. What do we do with it? Divided by 2. So to find the x part of it, we add them up, divide by 2. What do we do with the y's? Add them up and divide by 2. That's right. Take the y's, add them up, divide by 2, and that right there is your midpoint formula. Okay? So what are they going to do? They're going to say, let's do one really quick. Bell's going to ring, but just hang on just a second. Okay? What if you had these 2 points right here? And I asked you to find the midpoint of these 2 points. Find the midpoint. What do? Well, we make a big old ordered pair, right? We know we're going to divide them by 2. And what do we do here? We just add the x's. -2 plus 1. That's right. -2 plus 1. And then what do we do right here? Add the y's. 3 plus 5. See how easy this is? What's this going to be? -1/2. What's this going to be? 8 over 2, which is 4. That is your midpoint. Okay? I assigned a homework yesterday, but I assigned like all 3 things, including the slope. Okay? So do the ones, I don't know what the numbers are off the top of my head, but do the ones that are distance and do the ones that are midpoint. Okay? Everybody got it? I don't know what numbers they are. You'll have to look at it and see. So do the distance problems. It says find the distance between these 2 points. And then do the midpoint problems. Don't worry. The ones that say slope, don't worry about those. We're going to hit those tomorrow. Okay? Oh, I should have dismissed you 5 minutes ago, shouldn't I? Yep. I forgot it's Wednesday. They didn't have any bells. Sorry about that. I was thinking it was a regular day. All right. Have a good one.